Let's take a look at the derivative and the slope of a graph. Let's take a look at some pictures first to wrap our mind around the what we'll be looking at. Okay, so we have a graph here, and let me draw it a little bit differently. There, right there. And the derivative, we're going to introduce some concepts here. Try that one more time. Okay. We want to find a derivative at a point. Well, first off, let's look at the secant line. If I draw a point over here, as close as I can, coming through those points, like that, this has a certain slope to that line. That's a straight line. Use your imagination. And the derivative, or the slope of the secant line is equal to the change in y over the change in x. Well, here's our x-axis, and this axis here is our y-axis, or f of x. Well, if I were to come straight down from here, this distance right here from this point to this point is a distance of x, whatever that might be. Might be 3, might be 5. Actually, let me just put an x-axis here, not to confuse those x's. And if I were to go over to here, this would be y or f of x. Now, how that works out is whatever x value you have for this point, you just plug in your function. And of course, x is just x, so that's nothing real exciting there. Okay, now if I look at this point, come straight down, this has gone a certain distance. This is delta x, looks like a little triangle. This is a change in x, how much it's increased by. Well, if this point here, or this distance here is x, and this distance right here is delta x, then this one right here has to be x plus delta x. So this point here, let me choose a different color. This point right here is our x and our y. Or, actually I don't got room to do all that. Let's try it again. Okay. It's our x and our y, but then we said y was f of x. Used to doing this a little bit bigger area. This right here, our x value, if I go straight down, is x plus delta x. And then to find out what our y part is, we take that and we plug it into our function. Our function is f of x, so this is going to be f of x plus delta x, like that. Okay. So our slope of the secant line, change in y, so I'm going to take this y value, f of x plus delta x, minus this y value, which is f of x, over the change in x. So I have this x value, x plus delta x, minus this x value, which is x. Okay, so our slope of our secant line is f of x plus delta x minus f of x all over, x minus x cancels, all over delta x. Some parentheses there. There we go. Okay, so that's our formula. Now, as we move this this particular point here down closer to this line, and keep moving it closer and closer, well, if I were to go down here, what's happening is our delta x is getting smaller and smaller. Again, if I went down to here, my delta x would be from here to here. If I went down to here, it'd be from here to here. And as I keep getting closer and closer, delta x is actually going to approach 0. Now that's going to give us the idea of a tangent line. The tangent line touches at just one point. Secant line is 2 points. What the derivative is going to give us, this is a limit definition for derivatives. We'll see there's shortcuts in future sections. Our derivative, and what this is going to give us is it'll give us a generic formula that'll give us the slope of the tangent line at any particular point on our graph. And then if we plug in a specific value, that'll give us the slope of the tangent line at that point. So again, this is a generic formula to give us the slope of the tangent line at any particular point. And we said that the limit as delta x is approaching 0. So it's going to 0. And then it'll be f of x plus delta x minus f of x over delta x. So that's our formula we're going to be working with. And let's look at our first problem. Now I'm going to switch that formula up on you here in a minute. Delta x is kind of hard for some people to work with. I mean, it really has to be delta x to show the change in x. Okay, so number one, he says use the limit definition to find the derivative of the function. But then for ease of use, we're going to look at a better way. Okay, step one. Identify f of x. Well, that's easy. F of x is given. It's 9x plus 2. I didn't used to include this step, and then I'd get questions. Well, how do you get to f of x? It's like, it's given. I thought that was always obvious, but not to everybody. Step 2, find f of x plus delta x. That's this part of our formula. Well, this is just evaluating a function. So we got f of x plus delta x. We're going to go into our function, the 9x plus 2, and where our x is, we'll put in parentheses. Now remember, with evaluating a function, whatever is in the parentheses here will automatically be what you put in over here. This is x plus delta x. I put in x plus delta x. Now 9 times x is 9x. 9 times delta x is 9 delta x. And then plus 2. And then step 3, plug in f of x and f of x plus delta x into our formula. And find a limit. Try it again. Just couldn't get that to look right. Okay, there we go. And find the limit. Okay, so our formula says the derivative, that's f prime. There. I'll learn how to write here eventually. Okay, so we got f of x plus delta x minus f of x all over delta x. So we got the limit as delta x goes to 0. F of x plus delta x we said was this right here. So it's 9x plus 9 delta x plus 2 minus f of x, which we said in step 1 was 9x plus 2. All over delta x. Okay, now that we've plugged it in there, the problem with this limit is the delta x down in the denominator. Because if we put 0 in for that, we get a 0 in the denominator, which we can't have. Well, this one is just simple algebra. combine together like terms, so forth. Remember, a negative out in front of parentheses flips the sign of everything inside. So on top, I got 9x plus 9 delta x plus 2 minus 9x minus 2. Again, that negative flips the sign of both of those. Okay, so the 9x here and the negative 9x cancel each other. The plus 2 here and the negative 2 here cancel each other away. So we're going to be left with, up on top, 9 delta x. And down below, we're left with delta x. Well, this is 9 times delta x. So since that's multiplication, this delta x is going to cancel with that delta x. And we got the limit as delta x goes to 0 of 9. Now when you're evaluating a limit, you're going to take this 0 and you're going to put it in everywhere you have a delta x. We don't have any more delta x's left, so there's nothing to plug in, so our answer would be 9. That's our derivative. Now I'm going to switch up on this the next example. Instead of delta x's here, I'm just going to put h. And this is the derivative and the slope of a graph. Okay, so the derivative, that I can spell. Derivative and the slope of a graph, page 01. Okay. Now I'm going to change the formula. Actually, let me write the new formula down here, and then we'll work this problem. Okay, this is the derivative. Boy, it's been one of these mornings I cannot spell. Derivative. And this is a limit definition. Okay, so we got our derivative is going to be the limit as h goes to 0 of f of x plus h minus f of x all over h. I find that students actually do better on these problems if the delta x isn't there. For some reason, that delta x, they confuse it with x, and they are two different items. Now, it really doesn't matter what variable you use, because at the end, you're going to put 0 in for h anyway, so it's all going to disappear. So let's look at our next problem. Okay, so we got f of x is equal to x squared plus 3x minus 1. And we want to find the use limit definition to find derivative of the function. First step, identify f of x. Well, that's easy. It's given. Second step, we want to find f of x plus h. Well, we're going to take our function, and everywhere we have an x, we'll put in parentheses. Everything else remains exactly as is. Remember, with evaluating a function, whatever's inside the parentheses here is what you're automatically going to put in over here. So this is x plus h and x plus h. Now, x plus h squared, we have to rewrite as x plus h times x plus h. If everything's multiplication or division inside your parentheses, you can raise everything to the power. If you got a plus or minus, you have to write it like this. 3 times x is 3x, 3 times h is 3h, minus 1. X times x is x squared, x times h is hx, h times x is hx, and h times h is h squared, plus 3x plus 3h, minus 1. Combine together like terms. Hx plus hx is 2hx. plus h squared plus 3x plus 3h minus 1. And that's our f of x plus h. Okay, our third step. We're ready to plug everything into our formula and then simplify it. Remember, our formula says the derivative f prime of x is equal to the limit as h goes to 0 of f of x plus delta x minus f of x, oh, delta x, look at me. Okay, let's try it again. F of x plus h over f of x plus h minus f of x over h. Okay, so let's plug in what we got. The f of x plus h we said was all of this. So it's x squared plus 2hx plus h squared plus 3x plus 3h minus 1 minus f of x. Well, f of x, if I scroll up, was x squared plus 3x minus 1. So x squared plus 3x minus 1 all over h. Now again, this is just still a simple combine together like terms, and then we'll do something a little bit different. So we got x squared plus 2hx plus h squared plus 3x plus 3h minus 1. A negative out in front of your parentheses flips the sign of everything, so it becomes a negative x squared minus 3x plus 1 all over h. Now combine together like terms. Here we have an x squared minus x squared. Those are going to cancel. Here we have a 3x minus 3x. Those are going to cancel. Here we have a minus 1 plus 1. And those are going to cancel. So we're left with on top 2hx plus h squared plus 3h all over h. Now the problem is the h downstairs. If I put plug a 0 into the h in the denominator, we get division by 0. But up on top, I notice that they all have a h in common. So one of the techniques we have is to factor an h out. So that leaves us 2x plus h plus 3 all over h. Now if you got h times something up on top and then h down below, that since this is multiplication on top, the h's can cancel. And all of a sudden our h that was down below is no longer there. It's not causing us problems anymore. So we've got a limit as h goes to 0 of 2x plus h plus 3. And now we can do our direct substitution. We'll plug 0 in for the h. So I got 2x plus 0 plus 3, which gives us 2x plus 3. And that's our answer. That's our derivative. And let me save that. And then we'll work the next problem. Okay, so we got f of x is equal to square root of x minus 3. And again, use limit definition to find derivative. Well, our first step was to identify f of x. Very easy. It's given. F of x is equal to square root of x minus 3. Our second step is to find f of x plus h. And again, this is evaluating a function, so we'll go through and everywhere we have an x, we'll put in parentheses. Whatever's in the parentheses here will automatically go in over here. So we'll plug in x plus h. So that gives us x plus h minus 3. And then our formula. Our formula says the derivative is equal to limit as h goes to 0 of f of x plus h minus f of x all over h. So let's plug in what we're given. So we got the limit as h goes to 0. F of x plus h is this right here. So we'll get square root of x plus h minus 3 minus f of x, which was square root of x minus 3, all over h. Now, to simplify this, of course the problem is if we plug 0 in for h, then we get a 0 in the denominator. We're going to have to multiply the top and bottom by the conjugate of the top. And let's talk about what the conjugate is. Okay. Conjugate of the top. Conjugate means the first part is the same, second part is the same, sign in the middle is different. So the first part's going to be square root of x plus h minus 3. The second part will be the square root of x minus 3. Those don't change, exactly the same. But since this is negative, then this will be positive. And wherever you multiply by the top, you multiply by the bottom. So this will be square root of x plus h minus 3 plus square root of x minus 3. Now in the top part, when you're multiplying conjugates together, it's very easy. You multiply the first parts together, so you got x plus h minus 3 times square root of x plus h minus 3 minus, and you multiply your last parts together, so square root of x minus 3 times the square root of x minus 3. Now on the bottom, we don't do anything exciting with this. We just put them next to each other. We don't actually multiply them through using the distributive property. Now the reason why we do that is because we want that h to cancel, so we don't want it trapped in a bunch of other junk. Now when you got square roots and they're the same, like square root of x plus h minus 3 times square root of x plus h minus 3, they cancel each other away and you're just left with what's underneath. So we got x plus h minus 3 minus square root of x minus 3 times square root of x minus 3 gives us x minus 3. And then we got all this down below. Like that. Okay. Well, up on top, we got x plus h minus 3. Remember, a negative out in front of the parentheses flips the sign of everything inside, so it becomes a negative x plus 3 over all that. Okay, so up on top, combine together like terms. Here we've got x minus x, those are going to cancel. And we got negative 3 plus 3, and those are going to cancel. So we're left with limit as h goes to 0 of h on top, then h times the square root of x plus h minus 3 plus the square root of x minus 3. Okay, so down below we have h times something, and we have an h up on top. Since that's multiplication down below, we can cancel the h's. Now if it's plus, we can't do that, but if multiplication, we can. So we're left with the limit as h goes to 0 of 1 over square root of x plus h minus 3 plus square root of x minus 3. Now the problem was that h, and that h just canceled. So now we can just plug it in, do direct substitution. So I put 0 in for h, so I got 1 over square root of x plus 0 minus 3 plus square root of x minus 3. That 0 drops away, and we've got 1 over the square root of x minus 3 plus square root of x minus 3. Now since those square roots are the same, then we'll add them together. Since they're alike, we add the numbers that are out in front. 1 plus 1 is 2, so we've got 2 square root of x minus 3. And I suspect this is probably where they leave the answer. They don't actually multiply top and bottom by the square root of x minus 3. A lot of times in calculus, this is a little easier to work with. But anyway, that's our derivative. So let me save that. Time for my tablet to blow up. Okay, there we go. I'll bring up another tablet. And let's look. I think this is the last. Yeah, that's the last one. Then we'll look at the next type. Okay, so we got f of x is equal to 1 over x minus 3. Now, those of you who have seen derivatives before, you know that what we're doing, there's a lot easier way to do it. This is the theory behind it. Why does it work? If we were in Calculus 1, we would actually show how to derive some of those formulas using binomial theorem and so forth. We won't go to that extent in business calculus, but okay. First step, identify f of x. Well, that's 1 over x minus 3. Very easy. Step 2, we want to find f of x plus h. And again, this is evaluating a function, so wherever x is, we'll put in parentheses. Now, whatever's inside parentheses here will automatically go in over here. So we'll put in x plus h there. So that gives us 1 over x plus h minus 3. And then step 3, plug it into our formula. Okay, so we got, actually I forgot to put the f prime there. Our derivative, the f prime of x, is equal to limit as h goes to 0. F of x plus h is this one right here, so we got 1 over x plus h minus 3 minus f of x, which was 1 over x minus 3, all over h. Okay, now the problem with this one is if we put 0 in for h, again we have 0 in the denominator. Same story. But we're going to simplify it a little bit different. This is a, now a complex fraction is where you got a fraction inside of a fraction. Complex rational expression is where you have x's involved. But basically it's a complex fraction. And to get rid of a complex fraction, we multiply everything inside the complex fraction by the LCM of all our inner denominators. Now when I say inner, we have a fraction inside here and we have a fraction inside here. So our inner denominators will be based upon x plus h minus 3 and x minus 3. So our LCM will be x minus 3 and x plus h minus 3. And that's what I multiply everything by. So multiply by the first fraction. We'll multiply times the second fraction. And we'll multiply it times what's down below. Now we won't actually multiply it through because we want that h to disappear. That's what's causing us a problem. Up here the x plus h minus 3 cancels the x plus h minus 3, and over here the x minus 3 is going to cancel. So let's write down what we have left. So we have limit as h goes to 0 of x plus, or x minus 3, sorry, minus this right here, and then we got x plus h minus 3 over this. Okay. Now remember, a negative out in front is going to flip sign everything, so it becomes x minus 3 minus x minus h plus 3 all over h times x minus 3 times x plus h minus 3. Well, combine together like terms on top. You've got x minus x, those are going to cancel. We got negative 3 plus 3, those are going to cancel. So we're left the limit as h goes to 0 of negative h over h times x minus 3 x plus h minus 3. Well, now we have down below, we have h times something, and on top we have an h. So those h is going to cancel. And we're left with a negative 1 on top, and then down below we have x minus 3 times x plus h minus 3. Now the h out in front was what was causing us a problem, and it's now gone. So now we can do direct substitution, plug 0 in for our h. So we got negative 1 over x minus 3, and then x plus 0 minus 3. Which gives us negative 1 over x minus 3 times x minus 3, which is negative 1 over x minus 3 squared. And that'd be our answer. And let me grab a drink. And then we'll save this and look at our next problem. Okay, the instructions here say use the limit definition to find slope of the tangent line to the graph of f at a given point. So we got f of x is equal to x to the third minus 3x, and it's given 1, negative 2. I don't know what this graph looks like, but at the point 1, negative 2 on my graph, I'm trying to find the slope of the tangent line. Remember, the tangent line is a line that touches at one point, right at that point. Immediately around it, it's just not touching. Doesn't mean it can't touch somewhere else in your graph, so keep that in mind. But so this is the limit. Actually, let me write the limit down to begin with. So finding the slope of the tangent line at a point using the limit definition. So finding the slope of the tangent line at a point using the limit definition. Now our first step is to find f prime of x, find our derivative. Then the first sub-step within that is to identify f of x. Well, in this problem, f of x is equal to x to the third minus 3x. Our second step is to find f of x plus h. And we're seeing this. This is the same steps we just did. Okay, so f of x plus h, we're evaluating the function. So I'm going to take where my x is, and I'll put it in parentheses. Everything else remains the same. Now whatever's inside these parentheses is automatically what's going to go in over here. So I'll put in x plus h here, and I'll put in x plus h here. Now x plus h to the third power means x plus h times x plus h times x plus h. Negative 3 times x plus h. Negative 3 times x is negative 3x. Negative 3 times h is negative 3h. I'll bring down one of these x plus h's. Here we got x squared. X times x is x squared. X times h is hx. H times x is hx. And h times h is h squared. Minus 3x minus 3h. So then we got x plus h times x squared plus, combine together like terms, hx plus hx is 2hx plus h squared minus 3x minus 3h. And now multiply x plus h times that. So I'm going to take x times x squared gives us x to the third. X times 2hx gives us 2h x squared. And x times h squared gives us x h squared. H times, I should have put those in alphabetical order, but oh well. H times x squared is hx squared. H times 2hx is 2h squared x. H times h squared is h to the third minus 3x minus 3h. I say alphabetical order. That's not because I'm being picky, but it really helps you to pick out your like terms. Here's an hx squared. Here's an hx squared. So 2hx squared plus hx squared gives us 3 hx squared. Here's an h squared x, and here's an h squared x. This is an invisible 1 here, so we got 1 plus 2, so that gives us 3 h squared x. And then we got h to the third minus 3x minus 3h. And that's our f of x plus h. Well, our third substep within that is now to find our derivative. So our limit definition looks like this. We got the limit as h goes to 0 of f of x plus h minus f of x all over h. Well, all this long bit here is our f of x plus h, so we can plug that in. So we got x to the third plus 3h x squared plus 3h squared x plus h to the third minus 3x minus 3h minus f of x. I don't remember what f of x was, so let me scroll up. X to the third minus 3x. So x to the third minus 3x all over h. Okay, so we got limit as h goes to 0 of x to the third plus 3h x squared plus 3h squared x plus h to the third minus 3x minus 3h. And that negative in front of that parentheses flips the sign of everything. So it becomes a negative x to the third plus 3x all over h. Okay, combine together like terms. We got x to the third minus x to the third. Those are going to cancel. We got negative 3x plus 3x. Those are going to cancel. I think those are the only like terms. So they've got limit as h goes to 0 of 3h x squared plus 3h squared x plus h to the third minus 3h all over h. Okay, and we saw this technique earlier. Notice all my terms up on top have an h in common, so I'll factor an h out. And that gives us 3x squared plus 3hx plus h squared minus 3. Now up on top we have h times all of that, and then down below we have an h, so those h is going to cancel. You can only do that if it's multiplication up here. And that h that was downstairs is what was causing us a problem. So this is 3x squared plus 3hx plus h squared minus 3. Now we can plug 0 in for h, and this is our derivative. So this becomes 3h squared plus 3 times 0 times x plus 0 squared minus 3. Or our derivative is equal to 3x squared minus 3. And that's step 1. Okay, step 2. change our f prime of x to m and plug in the x part of our point now I'm going to say of our point given, so you know to look back up at the top. And then simplify. Okay, so that's saying change f prime of x to m, and then that's going to remain as is, but we're going to look up at the top here. They gave us a point. Well, this right here is the x part of our point, so x is equal to 1. So we'll come back down to here, and we'll put 1 in for the x. So where this x was, we'll put in 1. Well, 1 squared is 1 times 3 is 3, so we've got 3 minus 3, or 0. So that would be our answer. That's the, well, let me go over here. That's our slope of the tangent line to the graph of f at the given point. So let me save that. And let's look at our next problem. This says use limit definition to find equation of tangent line. So, problem number 6. Get f of x is equal to x squared plus 2x minus 4 at 1, negative 1. And these steps here are finding the equation of the tangent line at a given point using the limit definition. So finding equation of the tangent line at a given point using limit definition. Now realize, if we look at a graph, if we look at any individual point, they're all going to have their own tangent line. So this one here is different than this one here. So you got an infinite number of ones that are different, actually. When we're finding the derivative, that's going to be a generic formula that allows us to get the slope of any tangent line at any point. Any point where you can find derivative, that is, and it exists. Then we plug in our specific x value, and that gives us the slope of that tangent line. And now we want to find the equation of that tangent line, y equals mx plus b. So that's our goal in these problems, is to get this. Okay. Now our first step is still the same. Find a derivative. We still have our 3 sub-steps in that. Our first one is to find f of x, or identify f of x, sorry. Well, in this problem, f of x is equal to x squared plus 2x minus 4. Now our second sub-step is to find f of x plus h. Again, this is evaluating the function. We're going to go through, and everywhere we have an x in our function, we'll put in parentheses. So we've got parentheses squared plus 2 times parentheses minus 4. Again, everywhere there's an x, I just put in parentheses. Now whatever's inside these parentheses automatically goes in over here. So this becomes x plus h, and this is x plus h. Now x plus h squared, that you have to rewrite as x plus h times x plus h, because we have that plus in there. If everything's multiplication, that's where we square the x and square the h. Well, 2 times x is 2x, 2 times h is 2h, minus 4. Which gives us x times x is x squared, x times h is hx, h times x is hx, and h times h is h squared, plus 2x plus 2h minus 4. which gives us x squared. Combine together like terms, we got hx plus hx, which gives us 2hx plus h squared plus 2x plus 2h minus 4. Third substep, plug into the formula. Well, our derivative is equal to the limit as h goes to 0 of f of x plus h minus f of x all over h. So we got limit as h goes to 0. F of x plus h is all this. So we got x squared plus 2hx plus h squared plus 2x plus 2h minus 4 minus f of x, whatever that was. So let me scroll up. That was x squared plus 2x minus 4. So x squared plus 2x minus 4. Then all over h. Again, if you have a negative in front of your parentheses, then that flips the sign. So we're going to have x squared plus 2hx plus h squared plus 2x plus 2h minus 4. And again, this negative out in front flips the sign of those. So that becomes negative x squared minus 2x plus 4 over h. I'll combine together like terms. We have an x squared here minus x squared. Those are going to cancel. We have 2x minus 2x. Those are going to cancel. We have a negative 4 plus 4. Those are going to cancel. So up on top, we're left with 2hx plus h squared. My eyes are kind of running together there. Let me double check myself. 2hx plus h squared plus 2h. Okay. Now remember the little trick we had. Just so in case I start running out of room, let me continue over here. If all of your terms up on top have an h, you can factor an h out. An h out. So factor out an h, and that gives us 2x plus h plus 2 all over h. And again, those h's cancel. We've already talked about that before. And we're left with the limit as h goes to 0 of 2x plus h plus 2. And that h downstairs is what was causing us problems, so now we can plug in our 0 for the h. So we've got 2x plus 0 plus 2. So our f prime is equal to 2x plus 2. So that's step 1, find the derivative. Step 2, change f prime of x to m and plug in the x part of our point. So the f prime of x changes to m, and I'm going to take where my x was and put in parentheses, and let's go up and see what our x part of our point was. Well, this is our x and this is our y, so the x part is 1. So let's scroll down. I'll put 1 in here. So 2 times 1 is 2 plus 2, so we get m is equal to 4. And let's continue. Let's continue right here. Okay, step 3. Into the formula y equals mx plus b. Plug in the given point for x and y, and m from step 2, and solve for b. we got y is equal to mx plus b. Now if I scroll up, this is our x and this is our y, specific point. So we're going to plug -1 in for y. And for m, from step 2, we said that was 4. And then we'll plug 1 in for x. And then plus b. And then we want to solve for b. Well, 4 times 1 is 4 plus b. Take the 4 to the left side. We get -1 minus 4 equals b. And we get b is equal to -5. And then our last step is to write our answer down. It's asking us to find the equation of the tangent line, which is y is equal to mx plus b. And from step 2, we found m was 4, so plug that in. And from step 3, we found b was -5, so plug that in. So our answer is y is equal to 4x minus 5. Now, some of you may have learned a point-slope form, and that's fine if you want to use that, instead of doing the steps I did here, these last ones. I had some of you have heard this story. I had a student from Japan, 2 students from Japan one semester, and the girl, she sat in the back, and it was a 3-hour class. She slept every class. Came test time, she'd wake up, take tests, get her 100, go back to sleep. Now, he paid attention and realized both of these students had up through like Calc 2, Calc 3 in high school, but they were coming over here to get a degree, and they had to have a math credit, so they were taking college algebra. They both could have been teaching the class. And I asked the guy one time, I said, why do you pay attention? It's a weird question for an instructor to ask a student, but he explained. He said in his part of culture, he can't come to class and not pay attention. Now, she must have came from a different part of Japan where she had to come to class, but she could sleep. She got some good rest. He could have been teaching the class because he knew all of it. And well, he asked me one night, I was showing the slope-intercept form and the point-slope form. He asked me why I was showing the point-slope form. And I said, well, you need both of them depending upon what the problem looks like. And he proceeded to prove me I was wrong, that you can do everything with a slope-intercept form. And I like that. If I can find a step or formula that works 100% of the time, that's what I go with. Anyway, let me save that. He wasn't rude or anything about it. He just very respectful and just pointed out something I could change in the future, which I appreciated. Anytime I get the opportunity to grow, then that's I'm happy. I don't care who passes information on me. Okay, now let me maximize this so we can see it a little bit better. These are some examples that are functions that are not differentiable at x equals 0. Well, one of them is where you have a vertical tangent line. Remember, if you have a vertical tangent line, a vertical line, your slope is undefined. So that's why you can't find those aren't differentiable at x equals 0 for this one. Now, the second one is real obvious. It's got a hole there, a discontinuity. So you can't find a derivative at that point. Now, let's go to the one on the bottom right. This is an absolute value type. This is where you have a sharp corner node, and if you got a sharp corner like that, you can't find a derivative at that point. Now you can find it in other places, but you can't find it at that point. And if you have a cusp, like you see in this one, y is equal to x to 2/3, that's another example where it's not differentiable at that point. Can be at other places. You can find it at every other place, but not at where that cusp occurs. And that's actually all that section. So let me bring up the recorder, which is good. I've drank a little bit too much pop. And there we go. There's like no pause feature though. And let me press F10.